Welcome to homework.
Find the bandwidth and center frequency of the bandstop filter, and the figure is referring to the figure. The capacitance is written as 1 by SC, and for the inductance written by SL. Combination at the output is the inductor and the capacitor, which is in series. This can be written as R into SL plus 1 by SC divided by R plus SL plus 1 by SC. Here S is equals j omega. We can write this impedance as R into 1 plus S square LC by 1 plus SRC plus S square LC. Determining the transfer function, HS equals V naught S by VIS. Substituting here, the output voltage is the load impedance at the output by load impedance at output plus R naught. We can substitute the value here, R into 1 plus S square LC by R naught plus S, R naught C plus S square LC R naught plus R plus S square LC R. Substituting S equals to j omega here, then the transfer function in terms of j omega will be R into 1 plus j omega whole square LC by R naught plus j omega into R naught C plus j omega whole square LC R naught plus R plus j omega whole square LC R. The equivalent impedance of the circuit R naught plus ZS. This is equals to R naught plus ZS value is R into 1 plus S square LC by 1 plus SRC plus S square LC. The equivalent impedance will be R naught plus S R naught RC plus S square R naught LC plus R plus R S square LC whole divided by 1 plus SRC plus S square LC. Substituting S equals to j omega here into this equation, Z in will be R naught plus R minus omega square LC R naught minus omega square LC R plus j omega R naught C bracket close multiply 1 minus omega square LC minus j omega RC. This is divided by 1 minus omega square LC whole square plus omega RC whole square. To determine the center frequency, the imaginary part of the impedance must be 0. Therefore, substituting R naught plus R minus omega square LC R naught minus omega square LC R minus R naught plus omega square R naught LC equals 0. From here, the value for omega comes out to be 1 by root LC. Substitute the value of L and C, which is 1 into 10 raised to the power minus 3 multiply 4 into 10 raised to the power minus 6. Then omega value is center frequency 15.811 K radian per second. To determine the maximum value, R into 1 minus LC by R naught plus j omega R naught C minus omega square LC R naught plus R minus omega square LC R. For maximum value, j omega must be 0. Then the equation becomes R by R plus R naught, and for H infinite, it will be also R by R plus R naught. At omega 1 and omega 2, omega 1 and omega 2, the magnitude of the transfer function is 1 by root 2 of the maximum value of transfer function. Then 1 by root 2 into maximum value is r by r plus r naught will be equals to, simplifying it and taking the magnitude, 1 by root 2 will be equals to r plus r naught into 1 minus omega square LC by square root of r naught plus r minus omega square LC r plus r naught whole square plus omega r naught c square. Substituting the value for r 4 ohm, r naught 6 ohm, L as 4 into 10 raised to the power minus 6, and this is for capacitance, and the inductance value is 1 into 10 raised to the power minus 3. We get the reduced expression 1 by root 2 equals 10 minus omega square into 4 into 10 raised to the power minus 8 by root of 10 minus omega square into 4 into 10 raised to the power minus 8 square plus omega into 96 into 10 raised to the power minus 6 square. Reducing this expression and solving for omega, the equation becomes in the fourth degree, which is 16 into 10 raised to the power minus 16 minus omega square 8.09 into 10 raised to the power minus 7 plus 100 equals 0. Solve this expression to find omega square, which is 2.9 into 10 raised to the power 8 and 2.15 into 10 raised to the power 8. Therefore, from here omega 1 is 14.663 K radian per second and omega 2 is 17.029 K radian per second. And the bandwidth value, which is the difference of omega 2 and omega 1, this will be 2.4 K radian per second. This is the bandwidth of the bandstop filter.